order.
Okay, that's fine.
Let's get started.
Let's get started.
The first question: What are the non-functional requirements for the online coding evaluation system? We value availability over consistency. Means there could be delays, but the website or the APIs should be always on, and the coding execution should be isolated and secure. And we also need submission latency less than 5 seconds for scale to 100K submission per competition. Let's see. Get feedback. And core entities for this problem, we need a user, and we have problems, and we have submission, we have leaderboard. API, we need to support one view problems, and it will be get URL is problems, and query parameter like page equals to and limit like how many questions you need for a page, and it returns a partial list of all the questions, partial problems. Two, view a specific question, a specific problem. It will be get problems, a specific problem ID, return a problem, and optionally user can input the language they want. And three, user can submit. That will be a post problem submission, SID submission, and then number 4 for competition of the get leaderboard, CID, competition ID, and it will be a ranking of user scores, and these submit a problem. Body would be language XX and code string. Okay. View leader board. Okay. Next, how will you user be able to view the details of a given problem and code the solution. We start with a user. User is too small. Start with a user large. We have a primary server. Server, and the primary server store the result, store the submission query from main database, DynamoDB. It can be a traditional SQL DB or non-SQL DB. I choose DynamoDB because since the problems involves a lot of string, a document-based, a non-SQL database like DynamoDB would fit the request best, fit the requirement very well. PID, problem description, solution, code stub, submission, SID, code user ID, submit time. It starts with user click on a specific problem, and the API gateway, together with our primary server, query the database with the associated problem ID and return the problem to user, and the client render a code editor where user can code in. When user submit the code, the primary server save the solution to the DynamoDB, and the submission should also have problem ID so they can link together. I'm going to also add get problem ID. Okay. Make this otherwise. And another API user has made is a submit prom ID. Okay. Next question: how will users be able to submit their solution? Has their code executed and receive feedback on the result? so first of all, we can't execute the user's code on the main server because that violates isolated principle and expose our server to potential attacks. So I'm gonna use a Docker container to isolate the code execution. And the container is pre-configured with necessary runtimes. Like Java, Python, whatever required for executing the code. Java, Python. Okay. Connect. Next. Execute. Return result. Submission. It starts with user code in the code editor, and user click submit. Then our primary server send the associated code to a isolated Docker container which pre-configured with necessary runtimes. After the execution finishes, the Docker container would return the submission to the primary server, which store the result to DynamoDB and return feedbacks to user, which includes runtime, pass or not, and failed test case, if failed. How will users be able to view a live leaderboard for competitions? To support a live leaderboard, we will start with user view competition ID, and primary server query the database with the associated competition ID, competition CID problems, other metadata, and along with the competition, there would be a leaderboard and have a CID to match with the competition, a leaderboard ID, user score, submit at. To view a live leaderboard, the user enter the the user enters the leaderboard, and then our primary server queries the database with the associated leaderboard ID and return the sorted scores. If there's a tie, we can use the submitted timestamp to break the tie. I will change. List of ways that you support isolation and security when running users' code. As we mentioned, execution of external code should be isolated from our main server. To achieve that, we can do, there are several things we can do. Isolation and security. First and foremost, we can set timeout limits to prevent indefinite loop and excessively long-running code. Then we should set CPU and memory bounds to avoid exhaustion of resource and denial of service attack. Then we also disable network access. This would avoid unauthorized external communication. Also, plus the container is pre-configured with a read-only file system. This would avoid user to write any content or modify our content. All these methods combined with isolated Docker container would make sure our server is isolated and secure. There are a couple of things we can do. We should set up a timeout limit to avoid indefinite loop and excessively long-running code. We would also set a CPU and a memory bounds to avoid exhaustion of service and denial of service attack. In addition, we disable the network access to avoid any unauthorized network communication. Last, the container is pre-configured with read-only file system to prevent the user write or modify any files. These methods combined with the isolated Docker would make sure our server is isolated and secure. How would we make fetching the leaderboard more efficient and update in near real time without refreshing the page? query the main database to up in a level of near real time is very expensive. To support that, we can add a Redis live sorted set. When user submits the answer, the primary server save into both the sorted set and the main database. The Redis would see as submission ID and scores, something like that, or user. And when it's leaderboard, so I will use submission competition ID, CID. And when user view the leaderboard, we should add a endpoint that periodically pull the sorted set with top K scores. And on the front end, we would add like poll API, like view CID, that will periodically call this new API, and we would use JavaScript automatically update the DOM. This would give user a near real-time feel without refresh the page. I would add I think they are the same, but I would remove one of them. How would the system scale to support spikes of a submission during competitions while not dropping the request? In a competition, I need to define a competition. First, competition happened in a defined time, so that maybe thousands of users join this competition in the same time and submit in the same time. That's why there's a spike of submission. To avoid the spikes to break our system, I'm gonna add we can add a queue service, for example like AWS SQS, to buffer the traffic. Instead of sending the request to the worker directly, the queue is sent to a queue, and then we let the worker pull the request from the queue whenever resource is available. And then still the same. When the worker finish the execution, it return the submission to the primary server, who save the result to DynamoDB. I have to. This would make our system asynchronous. So we need another API to periodically check the submission ID, so that user would, when the result is not available, user would see your submission is still under processing. If it is longer than 5 seconds, we would give a timeout response. I have to record it. During the spike of submission, during competition, I would use a queue service to buffer the traffic. For example, AWS SQS queue service. And then I would let the worker to pull the request when the resource is available. In this way, it won't break our primary server, but this would make our system asynchronous. So I would implement a client-side API to automatically check the result, and when the execution finishes, the container was still the same as regular submission. The container would return the submission to the primary server, who save the result to DynamoDB. And the user use the client-side API to periodically check whether the result is available, and when it is, return to the user. And on the front side, we can show the user that your submission is under processing before the result is ready.